Okay, Assalamualaikum and very good evening, everyone. Can you hear me? Okay, boleh Okay, good. All right. So how are you doing? Good. Sudah ada semua dah makan Dah already have your dinner?
Dah doktor.
Okay, good. So makan, make sure ni lah awak make sure you have your dinner early lah, as early as possible, because biasa normally lah, after having a heavy meals, usually will take 2 or 3 hours before we can have a good sleep lah. So that's why for me, usually I have my own dinner either before Maghrib, before 7 o'clock, or maybe just after Maghrib solat solat tu Maghrib lah. So biasanya around normally after before 8 o'clock in the evening. So then I will have enough buffer before my sleeping time, 10 o'clock. 10 o'clock in the evening. So usually I will have my sleep 10 o'clock. So kalau macam awak mungkin you still young, so usually you will have your sleep very very late kan. But try to make it as early as possible, because then you can wake up early lah. Because working in the morning, early morning is much more efficient than in the evening. All right, back to power electronic. First, make sure everyone already fill in the select your timetable for practical test for this Thursday practical test. Ada lagi tak? Is there anyone still not select your practical test slot? Let me have a look. Power electronic. Check. Click this timetable. Semua dah. Still many people not choosing your timetable. So make sure choose your time, whether 11 to 12, 12 to 1, or 1 to 2 p.m. And make sure you try to arrange with your friend to borrow the laptop or whatever lah, if you don't have the laptop, because otherwise we might have tak ni kan, susah nak buat kerja lah. Tapi tak apa, at least we try to provide some laptop, but not sure whether it's going to work or not. And for the practical test, the question will be from the lab, from the topic boost converter. So just one question lah, boost converter. So try to look back into the lab sheet and your report as well. So and the practical test will be individual lah. So everyone need to make their own connection, and then I have to check your connection and give you the marks for the connection, and then after that you're going to do the test and take the result from the test, and then after that you can you have time for answering the question. So the total time will be 1 hour lah maximum. But usually I think 30 to 40 minutes should be enough for doing the experimental work, doing the connection and the testing. Eh? So all will be given marks. Your connection, the correct connection, your testing, and then your results, and also the question. Okay, so please select the slot for the practical test this Thursday. Okay, any question about this? Okay,
No,
so
doctor.
I assume you all okay with that. Now we're going to continue with the inverter topic. This one I just going fast because after this we try to finish this one, and then after that we're going to look into the AC to AC. Basically, for the AC to AC converter, we're going to look into next Thursday lah. Next Tuesday, next week lah. Next Tuesday, next week. Um, so that will be the final chapter lah. Um, for the final exam, the question will be from the uh, one question from the rectifier, one question from the DC to DC converter, and then one question from the inverter. Yeah, all the question will have theoretical and the calculation, and then one question from the AC to AC, AC to AC converter. Okay, okay. So back to the inverter. Last week, we already looked into the single phase inverter, and we already looked into the type of inverter and voltage source inverter, current source inverter, and then current regulator inverter. And then we also look into the basic principle of the full bridge square wave inverter, which have two leg, one H bridge lah, one H bridge. And then we also do the analysis how you get the square wave waveform from the DC input, from the DC input. So how which switch on and which switch is off during each cycle. Okay, so this one we already looked last week, and I I still don't have time to edit this the last week video, but after I managed to edit that one, then I will share with you lah, with you all. Okay. Okay. So last week we looked into this one basic principle of how the inverter works, how you generate AC waveform from the DC waveform. Okay. And then we also look into the half bridge square wave, and which basically you have peak voltage and a lower peak voltage half from the full bridge. And then we also look into the this one, the calculation. Basically for final exam, I think this equation you had is also in the final exam. I think you can try to do this one. You can try. Maybe we can discuss later on after this. We try to discuss this and try to do the this exercise, or maybe we can look into the example. Okay. Then we also look into the full width square wave for RL load. Then this one also exercise that you can try to do at home. Then we also look into the three-phase inverter. Three-phase. So basically, normally for three-phase, you can apply in your home as well. uh, because some of the home require three-phase supply, right? So that's why we have we learn about the inverter to generate the three-phase supply. Yeah? Okay, so this is how we control the system for the three-phase inverter. Okay, okay now this is all the equation and then the exercise. Okay, now we look into the basic lah. I'm going to do this look into this quite fast lah, because this is just mathematic. How uh, we relate uh, from the mathematic into the waveform lah. Then we can do the harmonic analysis, because at the end of the day, we want to come up with the uh, this waveform. Okay? So this line waveform, which represent the harmonic what's it call it harmonic characteristic of the waveform lah, okay, so basically for the inverter, study of the harmonic require understanding of the wave shape. So this equation, Fourier series, Fourier series ni basically the mathematical analysis lah, to understand about the shape of the waveform. So this is the main waveform. So basically we have A0, AN, and BN. So A0 is this one, and AN is this one, and each of these will have specific equation. So in order to understand about the harmonic, then we have to understand about the wave shape, bentuk gelombang, bentuk gelombang, wave shape. So in order to analyze the wave shape, we have to use the Fourier series tools. So basically for the Fourier series is a mathematical punya apa ni mathematical punya model that represent the wave lah. So saya rasa kalau macam dekat invitation, most of you actually, I'm not sure whether you already look into this Fourier series mathematical punya form lah. Have you learned about this before? Because my degree in UTM back in 2003 lah, 2000 year 2000 until 2005, and we have one subject just looking into the Fourier analysis. So we learn how to doing the mathematics about the waveform. But in your case, you don't need to seriously understand about this, just for the information, just for the information. Okay, so if there is no DC component in output, the output of the voltage and current will be this one, these two equation. So this is the equation for the output voltage, and we also have the output for the current, output for the current, and the RMS current of the loads is given by this one, di mana where IN will be equals to VN over ZN. So all of this IN, VN is ada their own model, where the Zn is the impedance which is R plus J omega X. X to either inductor or capacitor, depend. Okay, so therefore the total power absorbed by the load can be determined by this equation, where I squared the total of, so IN ni maksudnya dia punya harmonic lah, ada 1, 3, 5. So biasanya N untuk even number, even number ni nombor genap lah, even number 2, 4, 6 itu semua akan jadi zero sebab dia balance out. So we just look into the uh, odd number lah, odd number 1, 3, 5, something like that. So this is the total power absorbed by the load lah. Okay. Okay. So biasanya in the inverter, the input here is DC supply. So DC waveform dia like this lah. Flat waveform. So DC supply. So for example, this one is V in, and we supply. We have DC, for example, and then output of the inverter we will get this one, square wave. And square wave is not good for our device lah, for our appliance, because it's contain a lot of harmonic distortion, and that harmonic distortion will cause will affect your device, your appliance, in terms of the operation of your device, the reliability of your device, uh, the life cycle pun sama, dia akan pendek lah, akan cepat rosak kan. It will cause your device to get broken early lah. So it will require filtering. So this is the filter, inductor and capacitor. So inductor is to filter your current, smoothing, and the capacitor will smooth your voltage lah. So both of it combined will improve your shape from this square wave into sinusoidal. But the value of the inductor and capacitor will depend on how you get your output from the inverter lah. So that one is before your the output of the inverter we feed into the load. If we feed the square wave, your device, your load still working, but will cause a lot of problem lah to your device. So harmonic cause distortion to the output voltage. So low order harmonic, for example, third harmonic, fifth harmonic, are very difficult to filter. So biasanya usually we can filter the upper level of harmonic, like 7 harmonic, 9 harmonic, 11 harmonic, 13 harmonic. So that one is easy to filter out, and we can remove, because that high order harmonic is very low lah compared to the low order. Low order ni dia very significant. So biasanya low order harmonic, third and fifth, are very difficult to filter due to the requirement of the filtering size, and high filter order. So they can cause serious voltage distortion. So why we need to consider the harmonic? Kenapa? Why we not just use the output from the inverter feed into our load directly? So the problem is sinusoidal waveform quality must match the TMV supply. So TMV actually have their own requirement before going into the customer supply. Otherwise, because our device, our appliance is already tested at the smooth sinusoidal waveform. So that's why when we feed with non-clean waveform, distorted waveform, it will cause degradation for your device. So the main issue is the power quality issue. So this one you will learn in the power quality course, power quality subject. And harmonic may cause the degradation of the equipment. So that's mean the equipment will need to be derate. So dia punya rating dia akan drop lah. So the total harmonic distortion, THD, is a measure uh, on how we determine the quality of the waveform in our system. So, so this term THD depend on whether we look into the voltage or we look into the current lah. So if it's the voltage, then we can just write down THDV, uh, voltage, total harmonic dissociation for the voltage, and then for THDI, for the current. Okay, so this is the square wave output, fundamental and harmonic output. So we have this one fundamental, eh, and the third and fifth harmonic. So the higher order the harmonic, then your waveform will be ni lah, lagi compressed lah, lagi compressed compared to the fundamental one. But the amplitude is we can use this equation lah. Dia ada equation dia to determine the amplitude for each of the harmonic level. Okay, so this is the equation to determine the THD for the voltage. So the equation will depend on the RMS voltage for each third, fifth, seventh harmonic, and we divide by fundamental one. Fundamental is V1 lah. So dia punya n order, kalau n tu sama dengan 1, if n equals to 1, that means it is the fundamental harmonic lah, fundamental punya voltage lah. Okay, and for the current is the total THDI is square root of the total of RMS current square divide by the fundamental current, RMS fundamental current. Okay, so this is for the current, and then so let's say we have the square wave harmonic waveform, and from the Fourier series yang kita tengok tadi, that we look early, actually A0 will be 0 lah, and sebab dia first cycle and second cycle, bukan first cycle lah, this one, this cycle, and this cycle will balance out, balance out. So that's why we get 0. Same with AN as well. You will get 0 as well. Only BN je you will get the equation lah. Dia takkan jadi 0. So for BN, this is the equation here. 2 VDC over N pi multiplied by 1 minus cos N theta. So you use this one lah. So this one akan form the equation. So for this Vn, we have two situations. Either n is even or n is odd. N is even maksudnya n equals to 2, 4, 6. Ini kalau n is odd, dia 1, 3, 5. So if you put this value into your equation, you will get yang kalau even, dia akan jadi 0 lah. Harmonic does not exist on the even punya number of n lah. But untuk 1, 3, 5 ni, untuk odd number, and you will get this equation. Okay. So from this, if you put the value, you put n2 equals to 1, 3, 5, and 7, and if you plot the what's it called, harmonic spectrum. So this is called harmonic spectrum. Harmonic spectrum. Spectrum. Then you will get first how much. This is in the percentage, third, fifth, and so on until 11, 13. Even sometimes people look into 13, 15, depend on type of the waveform. Because some waveform might have high order of uh, no, the amplitude of the harmonic will be higher at the high order harmonic lah. But for square wave normally they akan drop uh, so not significant lah at high order harmonic okay, so harmonic decrease with the factor of 1 over n no even harmonic, and nearest harmonic is the third harmonic this one lah. So this is third and fifth actually the most significant lah. So that when we go to the 7, 9 the percentage is much lower lah. So due to the small separation between fundamental and harmonic, output of low pass filter design can be very difficult to design to implement into your system, your inverter inverter system. Okay, so compared to the square wave, we also have quasi square wave. So we call it quasi square wave. Why? You got 0, and then the amplitude positive cycle, and then you get 0 again, and then continue with 0 again, and then start with the negative lah, and then same back to the 0. So the 2 cycle basically same like square wave. A0 and AN will be equals to 0 because this one positive and negatives will be balanced out lah. So left with the Bn only. So you will have only Bn. Equation will be similar lah. So you will get this one. So same for the quasi square wave. Bn for the even will be 0, and Bn for the odd of n value will be this one. So you will get this one, cos and alpha. So where alpha is the angle, the angle. Okay. So this is the example that you can try to do, but I think it's not in the final exam, so you don't make your jangan susahkan diri awak lah untuk nak try buat ni. So try look into the question that will be in the final exam. Basically, question related to the full bridge inverter, single phase inverter. Okay. Now we look into the PWM. So PWM is important. Is related to the inverter in terms of how we control the output lah. So that's why we learned about the PWM. So PWM modulation is not just it's not only used in the inverter, but also we can also implement it in DC to DC converter to control our switch lah. So basically PWM modulation is related to the control of the switches because in the inverter we have 4 switches for single phase, and we have 6 switch for the 3 phase inverter. So basically it's very difficult to control each of the switch to make it nak make sure it's work properly. So that's why they come up with the pulse width modulation. The pulse width modulation provide a way to decrease the total harmonic resolution. So basically PWM ni dia control awak punya switching in order to achieve your output like a step. So they almost sinusoidal but not fully sinusoidal. So dia boleh buat awak ada cycle macam ni. So basically kalau square wave macam ni kan, tapi kalau for if using the PWM, you can increase your output step by step like this. Sampai 0. Same with the negative cycle, we go out like this. So it's almost sinusoidal lah. So it reduce the harmonic distortion, total harmonic distortion in your system lah. So type of the PWM scheme, so we have 5 method lah that can implement. So first is natural and sinusoidal sampling. Eh? This is the analog method, which is we can use the OM, the comparator method lah. So basically, usually this method used at early stage and before we have many option of the uh, digital control. Digital control. Right now we have so many uh, controller, PWM controller, like even the cheapest one, Arduino, eh, what's as Raspberry Pi, and so on. Even the expensive one, you can have Texas Instrument punya uh, controller, which you can control through MATLAB. So that one is digital one lah. Then you can implement other this four type digital one. But for the analog, basically we use the OM. We arrange the comparator lah, in order to to achieve your desired output lah. And then the second method, regular sampling. So this regular sampling, we simplify the version of natural sampling lah. So this one using the digital implementation. The third one is optimized PWM. So the constructed based on the certain performance criteria. So this one is compare the previous output and the harmonic punya performance. Then it's adjust the output lah based on the previous punya condition of the harmonic. And then the fourth one is the harmonic elimination, or we call it minimization of PWM. So this one is type of optimization. So to construct the system to eliminate some of the undesirable harmonic from the output spectrum. So basically, if you try to look into the IEEE website, if you search about this type of method, actually you can find a lot of articles about the implementation of this kind of the method. And then the fifth one is space vector modulation. So this one is simple technique based on the volt second. So this one basically used in the three-phase inverter lah untuk motor drive. Okay, so we have these five. So basically, just for your knowledge lah. Okay, so this is the natural sampling. So they compare rectangle punya waveform, we call it carrier form, to the modulating waveform. So they compare ni, you will get ni lah dia punya output lah, positive side, dia punya top dengan bottom, top dengan bottom. So and then this one is the what you call it, the equation to determine the amplitude of the modulation. So you guna ni lah, you determine from the VM reference and divide by VM carrier. So dia ada dua lah, amplitude modulation and frequency modulation. You can use this one. Okay, I think this one. Okay, so now we look into the advantage of PWM switching and also disadvantage. So for the advantage, the benefit of using the PWM switching is it provides a way to decrease the harmonic distortion of load current. So the amplitude of the output voltage can be controlled with the modulating waveform, and also at the end it will help you reduce the filter requirement. So that means the cost of the filter will be less lah. Otherwise, you will need bulk size of your capacitor and the inductor in order to filter out your output from the inverter. So that's the problem lah. So that's why if you implement the PWM switching, then you will save in terms of the filter requirement. So less cost, maknanya lebih untung lah kan. Good. So then in terms of disadvantage, PWM switching dia more complex control compared to the simple punya, because actually basically if we look into the basic principle of the inverter, basically we just need to control switch 1 and switch 2 on, and then during the negative cycle, switch switch 3 and switch 4 pula yang on kan, vice versa lah. So and that process will be repeated again and again. So that the basic principle lah. But in PWM, the on and off of the switching will be varied. So that's why it's more complex. So it's require complex control of the switches lah. So then it will cause the higher loss. If you increase the loss due to the more frequency switching, because we might increase our switching level, frequency kita punya frequency pun akan increase, then switching loss also will be increased lah. Okay, so this is in terms of PWM harmonic. Tapi yang ni you don't need to look into. Okay, so I just jump lah. Okay, that's it for the inverter. So we might look into the example. Let me see. Example. Yeah, last time I can't remember which one I share with you. Tutorial exercise or probably which one when I share with you? Let me have a look. Double check. Okay. Electronic tutorial exercise answer. Electronic tutorial. Right. Document unavailable. This one. Okay, let's try to look into. Okay, this one, the inverter, PWM, inverter, and the harmonic. Okay. So. Okay, for example, this one. Look into the square wave single phase full bridge inverter supply with the RLC load, RLC series load with resistor 9 ohm, inductor 50.93 millihenry, and the capacitor is 455 microfarad. So the fundamental of the output inverter current is 10 amp. So the inverter is operated at the frequency of 50 Hz. So this means you design the inverter to supply to your residential. So the first question, the equation is it asks you to estimate the DC source of the inverter. So DC source of inverter is VDC lah, VDC. Salah sikit, nampak. Okay. Okay, so this one. Okay, so this is the V out, and then this is I out. I out equals to V out over Z1 impedance. So and impedance is Z is equals to R plus J omega X. where kita masukkan ini R square plus X square. Or we can R square plus XL minus XC square. Ini lah. So kalau Z is equals to this, so you will get this one lah. So you put the value into here, and so XL is 2 pi FL. F ni, okay, SL is equal to 2 pi FL. L is the value of any inductor on inductor. This one lah, 50.93 millihenry. F is equals to 50 hertz. So you put into the value, then we get 16 ohm for the SL, and then for the XC is 1 over 2 pi FC. So dia opposite lah untuk kapasitor dia bottom one. So that's why dia minus lah. The minus. So this one for the impedance you will get 12.73 ohm. Daripada sini. So then from that you can get V out. So V out is equals to current. The fundamental output of the inverter current. So that's why dia kata I out 1. I out 1 is the number, specific number for the fundamental. So when the question mentioned about the fundamental, then it means I out 1. Then kalau harmonic dia either 3, 5 and so on lah. So I out 1 is equals to 10 ampere. 10 ampere. So then V out 1 fundamental voltage of the output you will get from the multiplication of the fundamental current times with the impedance, impedance Z1. So you will get 137.3 volt lah. So from there you can determine the DC source of the inverter. So DC source of inverter is V out 1 fundamental voltage times with the pi square root of 2 over 4. So guna equation ni. So you need to remember this equation. Then you will get this one, 141. Okay, then kemudian dia ask you to determine the RMS output voltage. So RMS output voltage is equals to VDC lah. So equals to VDC. V out is equals to VDC 141, same with this one. Okay, so in order to determine the instant, so yang ni, this one you need to express the load current up to 7 harmonic. Maksudnya that's mean you need to know this equation lah. So IN ni equation daripada tadi lah. So total of it's N 1 until 7 up to 7. So kena masuk equation ni lah. So basically kalau kat final, if at the final exam you will be given, I'm not sure whether it's given or not, the equation. Okay, the equation is given. The equation is given, but you need to know how to use it lah. So this equation basically is given, but you know how to use this equation to get this one. So basically kalau if you look into this one, you will have two terms, this one and this one, for each of the n equals to 1, n equals to 3, n equals to 5, and n equals to 7. So that means you need to find delta 1, delta 3, delta 5, and delta 7, and also you need to find the Zn, Z1, Z3, Z5, and Z7. So each of these kena ni lah, you have to calculate. So different n value, you will get different what you call it, different impedance value lah. So but it's easy because the first one, Z1, you already calculate at the top one, right? This one. So the difference between uh, Z1 and Z3, Z5, Z7 is you just add n value here. So just multiply lah. Sama ada either 3, 5 or so on lah. 7 and so on. So for example, untuk Z5 ni is R square plus n dia is equals to 3 kan. So n ni 5 kan. N equals to 5. So this one is XL minus 1 over XC n square. Okay. So put the value, then you will get Z1, Z3, Z5 and Z7. So then from that you will get the value. For example, so yang ini, this one is n equals to 1. Okay, n equals to 1. And this one is n equals to 3. And this one is n equals to 5. Okay? And the last one is n equals to 7. And so each of this, if you look into it here, Z, okay, Z kat sini ni dimasukkan kat sini lah. Sin omega ni dah omega t. Omega t is same. So you just put the value of theta, either 45 untuk theta 1, theta 3, 78.85, same. And then for n equals to 5, just put theta 5, 83.47. And then for theta 7, you get 85.36. And cuma the only problem is in the front here. So front here you need to calculate lah. So maknanya the difference is, for example, n equals to 1. So you will get 4 BDC is from here. BDC, you have to calculate this one. 141.39 times we say 4 divide by if n equals to 1 times with a pi. So then itulah, and masukkan, you will get the value lah. So same with other, you have to divide by 180 over 3, 180 over 5 and 180 over 7. Cuba buat ini, you try to do it and then let me know if you're having a problem to get the answer lah. Okay, this one divided by this one is N. Okay, then the third question is state to advantage. So ni you can get from the slide, and then for first question, I think basically similar to the second question. You can try to do it based on the second question. Try to do these two questions. Question 2 for the inverter topic, and question 4. Question 4. So both of the equation basically almost similar to the question in the final exam lah. So try to do and understand this exercise. So hopefully it will help you to work with the final exam lah. Okay, so I think that's all for inverter topic. For next week, we're going to look into the final topic lah, about the AC to AC inverter, AC to AC converter lah. So basically we already for the past almost 14 weeks, we already look into the AC to DC rectifier, and then we also look into the DC to DC converter and chopper, and then last week and this week we look into the inverter and DC to AC. So for the last week, next week week 14 kan, we will look into the AC to AC converter last topic of the power electronic. Okay, so any question for tonight topic? Ada soalan tak? You can either write down in the um, comment or you can ask me. Boleh, you can either ask in bahasa Melayu pun tak, no problem. You can ask in bahasa Melayu or you can ask in English. Ada soalan tak? Tak ada soalan. Okay, no question. That's mean we at the end of our session tonight. Okay, so thank you very much for spending time and try to understand about the inverter topic lah. And anyone that still not register your attendance, just wait, and then everyone else who already done the attendance can left lah. Alright, so thank you very much and selamat malam. Take care, sleep early. Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, siapa lagi yang belum fill attendance?
Thank you, Doktor.
Okay, sama.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Okay, welcome.
Doktor, attendance tadi belum.
Okay, wait. Attendance. Let me open first. Okay, let me share. Okay, siapa lagi host?
Kalai ni lah, Doktor.
Kak Lanila, okay. Dan
Norma mudah.
Nombor 7.
Lim Gowe Gordon. Okay. Dan
Muhammad Hakimi, Doctor.
Muhammad
Hakimi.
Muhammad Hakimi, okay. Hakimi dia dah.
Thank you, Doktor.
Alright, sama.
Thank you, Doktor. Norma
Sama.
mudah.
Norma Muda. Okay.
Terima kasih, Doktor.
Okay, sama. Okay, Nur Ahmad ni ada. Aifa belum ada. Nur Ahmad ni Izzatin ada. Tamizi ada. Okay, alright. So thank you very much. Assalamualaikum.